of Neuchâtel in Switzerland. I would like to thank the Council of the Academic and Scientific Poznań, as well as the Faculty of English, for making this open lecture possible. Professor Martin Hilpert is a cognitive linguist, a corpus linguist, a construction grammarian, as well as a diachronic linguist, and he's among the most respected and recognized figures in the field. He obtained his PhD in linguistics in 2007 from Rice University, which was followed by 2 postdoctoral fellowships, one at Berkeley and the other at the Freiburg Institute for Advanced Studies, where in 2012 he was granted his habilitation. He's now professor of linguistics at the University of Neuchâtel, where he's been working since 2012. To list all the details of his publications would go well beyond our time here, so let me just tell you that Professor Hilpert has published over 80 articles, chapters, edited volumes, as well as monographs with top publishing houses, including Cambridge University Press and John Benjamin's. And particularly famous with linguists are his 2008 Germanic Future Constructions, 2013 Constructional Change in English, and 2014 Construction Grammar and its application to English. Professor Hilpert is also very active in the linguistic community, having presented the results of his research at over 60 conferences. And only in the last 8 years, he's delivered 15 plenary lectures. Importantly for us today, he's also a wonderful, excellent communicator and pedagogue. Suffice it to say, his videos where he discusses various topics in linguistics are popular all over the world and have thousands of viewers. I can see people nodding here, so yes. Okay, so once again, it's a great honor to be able to introduce Professor Hilpert. Martin, thank you so much for being here with us today, and the floor is yours. Thank you.
Thanks so much.
Yes.
Perfect.
We cannot see it on the screen.
A small technical break.
Which I will use to thank Carolina for the introduction. That was really far too generous.
It wasn't.
This is a bit of context. This is my first trip since COVID, yeah, and I feel like I'm being let out of the house again. And I'm so glad that it's to Poznan, because of all my friends and colleagues that I have here and the fond memories that I have from conferences that I've been to in Poznan. So I'm really, really happy to be here with you today. So it's a great pleasure. And I'm also a bit excited because, well, I'm supposed to give a lecture that addresses the general public. Now, I recognize many expert linguists in the audience, and I have to say that makes me a tiny bit nervous. Yeah. However, I hope that for the experts among you, there are at least 1 or 2 things that you can maybe steal for your teaching or for party conversation. So this will be lighthearted, just to prefigure what I'm going to say. Depending on how chatty I will be, this is going to take maybe an hour or so. Okay, so just to give you a general idea. Now, I'm thankful that you have showed up for a lecture with a somewhat mysterious title behind the words on the new cognitive science of language. Well, that borderlines clickbait, right? So what I'd like to do in the time that we have together today is to share with you all a few ideas on a phenomenon that is familiar and well known to us, namely language. We're surrounded by language every day, and everyone in this room speaks at least 2 languages, if not 3 or 4. So we're professional and experienced language users. We have some authority to the claim that we know what language is. But do we? Yeah? Once we sit down and think about language and try to describe what it is, how it works, what is it that we can actually say? I'm looking at the linguists in this room. Occasionally you're being asked to explain to friends and relatives what the hell it is that you're doing, and there are some awkward situations going on there. I would suppose that most of us would say that language consists of words and then ways of putting those words together in order to communicate with others, to get meaning across. And that's true. There's nothing wrong with that. But here we get to the title of the talk. What is going on behind the words? What is happening in human minds that allows us to use language so proficiently and so effortlessly? So this talk is an invitation to take a step back and to look at language, hopefully in a new light. So I'll try to give you a perspective on language that is currently shared by a fairly large community of linguists, cognitive linguists, and I'll be talking about research that has been carried out over the past 2-3 decades and that supports this view. So it tries to give us an understanding of what language is, what lies behind the words. Here's an overview of what I will have to say. I'll start this talk with an image, namely the image of a forest. So like language, forest is a complex system in which everything is connected. So in order to understand the organisms that make up the forest, we need to understand the biological, chemical, physical processes by which they are related. So, and by analogy with language, if we are to understand what is going on behind the words, we need to have some insight into the processes that come together in language. And the central argument of this talk will be that the human ability to use language rests on a set of cognitive and social skills that we all share as human beings. So what makes language possible is a combination of abilities that are not themselves linguistic, but that instead provide the foundation for everything that we're doing with words. I restrict myself here to 6 processes: joint attention, intention reading, categorization, pattern recognition, analogy, and metaphor. And the goal is to show how each of these processes are implicated in language and how the different pieces fit together. And my hope is once that we have this general background, we can take another look at the forest and then see a few things in a new light. Things that have escaped our attention before and that are now open to inspection and discussion. So without further ado, let me come to the first part in which I want to make a few general remarks. To get us on our way, I brought you this picture. That's actually taken not far from where I live. So I try to visit that place once or twice a week when I go for a run. And if you take that path and follow it a little bit for a few minutes, you can see the Swiss Alps on a good day. It's gorgeous. It's really, really nice. Well, I've brought you this because to the untrained eye, the forest is just an arrangement of plants and animals that are living in the same space. Yeah. So maybe you have 2 different tree species that are there, and it all looks quite random. Yeah, but to a biologist, all of that makes sense, and there are explanations behind that. So the 2 different trees might thrive in close proximity because they have complementary needs for nutrients in the soil. Yeah? And then their leaves and their pines fall down, and they're used by microorganisms, and that changes the mineral content of the soil, and then new plants are allowed to grow, and the cycle repeats. So there's a world of processes going on behind the elements of the forest. And the insight that I'd like to bring across is that, this finely balanced network of interdependencies, that applies also to language. So there's an important difference between biology and linguistics. So for biology, we all share this basic knowledge that biologists have come up with, and the concepts that biologists use, they reappear maybe in simplified form, but they are being used by ordinary people, let's say, and they're even known to school children. Now, linguistics has not quite managed to make its ideas common knowledge in quite the same way. So even the most basic of concepts, phonemes, morphemes, pragmatics, syntax, semantics, and so on and so forth, all of that remains relatively obscure. And if we're completely honest, it's actually worse than that. So everyone in this room is able to name at least a handful of big scientific achievements from the natural sciences. Now, what are the big breakthroughs in linguistics that you would name? Yeah, if someone would corner you, and if you can come up with one or two, be honest, are those achievements from the current century? Probably not. Yeah. So what this boils down to is that linguistics has something of a PR problem, for most people, the understanding of language remains relatively superficial, like a mythical forest, not a biological forest. Yeah. Okay. So you begin to see what I'm trying to do here. If you have a passing experience with linguistics, and I know many of you are experts, lay people will have heard the name Noam Chomsky, sometimes being called even the father of modern linguistics, who has championed one well-known theory of what is going on behind the words. So the key elements for Chomsky's theory, what he and others have called universal grammar, would be that there's a general human capacity for language that is shared by all of us. And that theory has been formulated in different ways since its original inception. But one element that has stayed central and has stayed the same is that the capacity for language emerged in our species as a mutation and is therefore encoded somehow in human DNA. So the argument goes that as humans are the only species that have language, there must be something language specific about our genetic makeup. That's a fascinating theory, and it has prompted really a steady stream of arguments and counter-arguments that I won't review here. But I will say that what you are about to hear represents something of a departure from Chomskyan thinking, an alternative to universal grammar. That alternative, however, still aligns with Chomsky in very important ways, and those are the three aspects that you see on this slide. So Chomsky argues that language is uniquely human, and I do agree. Yeah? So animals are proficient communicators, but there are characteristics that we can apply to make the argument that language is qualitatively different. Chomsky also argues that language is universally human. Again, I agree. In all human cultures, language is present. And he further holds that language is a cognitive phenomenon. So understanding human cognition is really fundamental to understanding language. And again, I couldn't agree more. So while I fully share these points, I'll try to convince you that the processes that make language possible are not themselves specific to language. And that's where we part ways. Yeah? So instead of a universal grammar, cognitive linguists believe that language works due to several cognitive and social processes that provide all the support that is necessary for language to emerge in humans. Let me flesh that out just a little bit. So the notion that language is supported by so-called domain general sociocognitive processes, that's a long word, that has been expressed very clearly in the work of Michael Tomasello, who you see here. The general idea is that language draws on several processes, including categorization, association, routinization, and a few others. Yeah? And whereas Chomsky linguists assume that we come into this world with knowledge that is specifically linguistic, not specific in the sense of specific to Japanese or Korean or Polish or French, but rather specific to the linguistic capacity. Linguists who are following Tomasello work on the assumption that there's a specific combination of general cognitive and social skills that is actually enough for a basis of language learning and enough to explain why humans have language and other species don't. In other words, we can view language as an emergent phenomenon, something that is brought out by several components, and those components interact, and the resulting event, the resulting characteristic of what comes out has properties that the parts do not possess. Yeah? Tomasello, of course, puts this much more succinctly than I ever could. What he says is that children acquire all linguistic symbols of whatever type with one set of general cognitive processes. Yeah? That is really the basic idea. That, if you like, is the general question that I would like to discuss in the rest of my time today here. And I would like to give you examples for the kinds of processes that Tomasello has in mind and how they come together in language use. So by the end of the talk, I think you will be in a position to assess the general logic of the argument. Yeah? Do we need something more, or are these domain general processes enough? And I will let you judge for yourself if you consider Tomasello's hypothesis a worthy alternative to the Chomskyan theory of language. Okay, where I'd like to start is the process of joint attention, which incidentally is something that we're doing right now. We're focusing together on some item of interest, a set of ideas in our case. Joint attention is a skill that is present in children long before they are able to use language. So we can define it as the ability to focus on an item of interest together with another human being. That may sound very abstract, but I think you'll perfectly understand the concept on the basis of a very simple example. Now here I have to see if I can get this to work. So, oh goodness, it works on this screen here. I'm not quite sure if it works on the video on FaceTime.
It doesn't yet. Hopefully,
you know what?
We'll
that's a bit of a shame, but I've made screenshots of the important bits. Yeah. So you can kind of imagine what is going on. Oh, wait a second. Here we are. Okay. So basically, we're having a family breakfast. Yeah, and this is my son at about 1 year of age, and at that time he was a pre-linguistic human being. Okay, so no words, not just yet. Yeah. However, he was already a very skilled communicator. Yeah. Not because he was especially gifted or anything, but no, kids at that age are. Yeah. So what happens in this episode is that he keeps pointing to a piece of bread that he would like to eat. But more than that, he draws my attention to that bread because there's a crucial flaw with it. It doesn't have any jam on it. Yeah. So you see him pointing to the bread and subsequently looking up to me to make sure that I have picked up on the important issue at hand. Yeah? And that goes on back and forth throughout an episode that lasts about a minute or two. Yeah? Now, joint attention is I said the skill to focus on an item of interest together with someone else. And children engage in this behavior from a very early age onward, about 9 months. And then they use this behavior to engage and maintain interactions with their peers and their caretakers. And if you're wondering why that is important for language, the key element is that in an episode of joint attention, the child knows that its own experience is the same as that of the other person. We're focusing on something together. So linguistic sounds that are heard in that situation tend to be associated with the shared experience. The words become meaningful. And we know from empirical studies that time spent in episodes of joint attention correlate with increased vocabulary size 12 months later. Okay, so the more chances you have to overhear meaningful sounds, the more words you will know 12 months later. Yeah? Now that said, there are of course individual differences, but as a general tendency, that holds. And what it means is that joint attention and language learning are actually mutually reinforcing each other. So what you've seen in the little picture of my son is that joint attention is often initiated through pointing. So pointing, that's an important element. And children point for various reasons. Of course, they do point to things that they want. Yeah, give me that. We've all seen that, all experienced that. However, it doesn't end there. Children also point to things that they want an adult to manipulate. Yeah, think of the piece of bread that doesn't have any jam on it. But also opening a box that is difficult to open, or turning a picture book to the right page, not the wrong one. Yeah? So those are important events. And finally, children are also pointing to things that they consider interesting. So here you see my daughter pointing to a plane flying overhead in the sky, not because she wants that plane, not because she wants me to do something to that plane, but rather what she's thinking is, look, there's a plane, isn't that cool? Yeah? I thought you might be interested in that. So children from a very early age onward, even when they're pre-linguistic human beings, feel the need to communicate ideas, to share ideas with others in a collaborative way. Now, of course, I'm trying to seduce you into this idea with cute pictures of children and things like that. But actually, you don't have to take my word for this argument. Here's experimental evidence. So this is an experiment that has been carried out with 12-month-old children. And the experimenters created a situation in which the child was sitting between two adults. So this is the child, two adults, parent, experimenter. And at the other side of the room, there is something of a puppet theater situation going on. Yeah? So there's a screen with a couple of doors, and occasionally something interesting happens. So here you see a puppet sticking out its head. And of course, what the child does, it realizes that, oh, there's something going on, and it points. Yeah? Now, the point of the experiment was to see how the child would react to different behaviors put on display by the experimenter, the person who is in on the experiment. And there are 4 different reactions that the experimenter gave in response to different interesting events happening. The first one is joint attention, the kind of reaction that we would expect from an ordinary human being, an ordinary parent. Yeah? So the experimenter looks back and forth between the interesting event and the child, and also talking in an excited way about the stimulus. Yeah? Now, there are 3 other conditions. In one condition, it's called the face condition, the experimenter reacted with excitement, but was only looking at the child's face. Because, oh yes, you're pointing, that's great. So I can see in your faces that's not what we want. Yeah? There was a third condition in which the experimenter looked only at the event, but not back at the child. Also that. Socially, well, a bit off. And then the most boring condition was the one in which the experimenter didn't react at all, Yeah? Not looking at the event nor at the child, just at her hands, pretending that nothing is going on. Now, I don't need to ask you which condition you think prompted the most enthusiastic response from the child. So, of course, the pointing gesture of the child was held the longest when the adult reacted with joint attention. Yeah? So you clearly see the joint attention reaction pattern that gives us a different results from the three others. Yeah? No surprise there. But what is perhaps a little more surprising is a second measure that the researchers did, namely how long or how often the infant looked to the experimenter's face. And here we see the event condition jumping out. Yeah? So we have the adult looking at the interesting event, but not back at the child. And here the child is really confused, looking at the experimenter's face. So look, you've recognized the interesting bit. Now we should share this interesting insight. Yeah, but somehow the adult does not. Yeah, so that's how you get this result. So the bottom line is, if I point out something interesting to you, I expect you to look at it, but I also expect you to look back at me so that we can share this episode of joint attention. And that is pretty much exactly what you see in these pictures. Yeah, so that is the typical reaction of pre-linguistic children in these kinds of situations, and that is also what's happening in the experiment. So the bottom line is that children want to share information, and they're not satisfied just by getting attention, which is something that you could think. Yeah? No, they want to have attention for the right reason, and attention that is being focused and shared on the right event. Right. Joint attention, important predisposition for language learning. And importantly, this skills interact with another human cognitive capability, namely intention reading. Intention reading, that's something that you could also call mind reading. What I mean by that is that, well, young children interpret other people's actions as purposeful and goal-directed. Philosophers have a term for that. They call it theory of mind, the idea that other people have ideas, feelings, knowledge states just as we do. Things go even a little bit further than that. So children from a young age onward understand that intentions often have a collaborative character. Yeah? So let me give you an example for that. Intentions are often collaborative, and by virtue of that, they promote word learning. So this is another experiment in which a child is being exposed to a new word. So again, it's set in a situation where we have an experimenter and a child interacting, playing with toys. And here the experimenter suggests a new idea, saying, for example, you know what? Let's go and find the toma. And at that point, toma is not a word that the child has heard before. So what happens is that the adult leads the child to a toy farmhouse like this, tries to open it, but unfortunately it is locked. The adult gives an impression of being disappointed, and then shrugs after a few minutes, leads the child away and says, okay, we'll do something else. Yeah? So they're playing with something else for a few moments, and after a while the adult asks, okay, tell you what, can you get me the toma now? I have a feeling it might be possible. Yeah? And so the child returns to the farmhouse, which now is open, and retrieves a strange looking object from the inside. Yeah? Reasoning that, well, this must be the toma. Yeah? It's actually a garlic press, if you look at it, but it's a utensil that the child wouldn't have seen in that form before. Okay, the important lesson is that it was through reading the intentions of the adult that the child concluded that, all right, so we wanted to find the toma earlier. Now, here I find something that corresponds to that, so that must be a thing that is called the toma. So no one ever pointed to that thing and said, look, this is called toma, just so you know. Yeah, it's the child figured that out on its own. Okay, that's interesting, but what is perhaps even more interesting is that children appear to presuppose that communicative intentions are typically cooperative. It makes sense for us to look out for other people's states of mind because more often than not, these other people will have our interests in mind. Sounds great, right? So, but let me show you some evidence to demystify this a little bit. This is another experimental setup involving a child, yeah, and then on the other side of a table with 3 interesting-looking containers, there is a person that is called the hider and a person that is called the communicator. And the experiment works like this. So at first the curtain is open and the child is shown something of interest. Yeah? Maybe a sweet or something that is interesting enough so that the child desires it. Then the curtain closes and the hider hides the reward in one of the 3 containers. The curtain opens again and the child is allowed to pick one of the containers. Yeah? Now, it sounds like a kind of fishy game to play with a young child. However, things are not quite as malicious. There's the communicator, and the communicator gives a hint, helping the child. And the hint comes in 3 different shapes. So the first kind of hint is pointing. The communicator points to the container in which the reward was hidden. The second type of hint works in such a way that the communicator has a small marker, a small dice, putting it on the container in which the reward was hidden. And in the third condition, the third type of hint is an object that looks just like one of these containers, and the communicator holds that up. That's like this. Okay, now what happens? And again, it's not going to be a surprise to you or to anyone who's interacted with children. The children will latch onto the idea that, okay, it's pointing to that, so that's probably the container where I find the reward, and indeed they do. Yeah. So pointing works best. Now, what you see in those results, so how often out of 6 trials do the children get the thing right? So pointing works best, the marker a little less so, the replica strategy, well, children are still above chance, but it's more difficult. So, in other words, young children work on the assumption that the people who communicate with them are trying to bring across helpful information. And information that is beneficial to them and not necessarily for the person who is communicating. Yeah? So there would be alternative interpretations. Yeah? So the communicator might be pointing to the container because that's what they want. Yeah? Give me that. But no, the child interprets that as a helpful communicative gesture. If we repeat the experiment with chimpanzees, so this has been done, there it emerges that the results are not at all the same. So our closest evolutionary relatives don't behave in the same way. So even with pointing, chimpanzees and orangutans are pretty much at chance level or even below that. And this is in line with other results that seem to indicate that human communication is cooperative, helpful, but communication in great apes is not, at least not to the same extent. Yeah? What this boils down to is that intention reading reveals an important difference between human beings and our closest relatives, so that humans are naturally helpful communicators, and even young children behave in that way. And non-human primates tend to be more competitive in their communicative patterns. So imperatives and threats, okay, that works, but non-human primates don't assume that information is provided by others in order to help them. Okay, I think you can already see how joint attention and intention reading represent important foundations for language as we know it and the acquisition of language. However, there is more. And with that, I'd like to come to categorization. So language really wouldn't be what it is without the very basic and foundational capability of categorization. So perceiving things in the world as instances of more general kinds. Okay, language, of course, reflects this. If you take a simple word, such, for example, bird, you've all seen this picture. So when I say the word bird, the first thing that comes to your mind would be a prototypical bird, such as a robin, but the word, of course, applies equally to parrots, ducks, penguins, and so on. And the fact that our words work in this kind of way shows the human ability to abstract away from specific details and to extract commonalities that apply across different tokens of experience. Okay, and well, contrary to classical philosophical accounts of categorization, we know that our ability to categorize is very much sensitive to content. So again, this is something that many of you will know. If I were to ask you what this item would be called in English, I have a very good chance of obtaining a high percentage of responses that call this thing a cup. So here, I would still call this a cup. Yeah, maybe, probably. Here, honestly, I'm no longer sure. Yeah. And that one, okay, so that's not a cup. It's kind of a weird thing that, well, it doesn't look very bowlish either, but if I were really forced to use a label, I'd probably use that. Yeah. Okay. Now, here you see some empirical results from classic study by Leboeuf confirming these informal impressions. So the first three items are labeled with the word cup relatively consistently. After that, there's a big break. And that is when participants are told nothing about the content. However, when the participants are told that the container is made for food, so here you have something, and by the way, you put broccoli in it. So that then is definitely not a cup, but rather a bowl or some kind of serving plate or whatever else you want to call it. So what this shows is that our labels for things don't just reflect inherent characteristics of things in the world, but rather they reflect also the intentions of what people want to do with it. So again, intention reading comes in and it interacts with our categorization ability. Categorization is really ubiquitous in language. It's not just reflected in the words that we use for things, but also at a somewhat more abstract level for the syntactic structures that we use to describe situations. So also syntactic patterns and situation types are categories. Quite often we don't have names for those even, yeah? But they exist nonetheless. Let me give you an example. So here we have the two most studied sentences of English. So John gave Mary the book and John gave the book to Mary. Superficially, they express the same state of affairs, the same event. And the syntactic shapes that characterize the two sentences are linguistic categories. So just like cup and bowl, you know, a bit more abstract, of course, but the same general principles apply. So sometimes a speaker may choose the first variant and sometimes the second. And the reasons for that would be that, okay, here I have an expression that fits a category that I have, you know, an image of a situation that I like to express with this syntactic shape. It's really the same thing as the cup and the bowl. Yeah? So I have a situation where this label applies to a situation in the world. Yeah? But here, of course, the linguistic sign is more complex. Okay, so what then are the reasons that people choose one or the other? That has been studied, I don't want to say to death, but extensively, if we want to call it that. So, for example, if the person who is receiving the book is well known both to the speaker and the hearer and is thus expressed by a pronoun, well, we prefer the first variant. By contrast, if the thing that is being transferred is well known and thus expressed by a pronoun, speakers have the inverse preference. They strongly prefer the second one, and the first one is just about ungrammatical for speakers of English. Yeah? So you can test this with your own intuitions, but I'm sure, we would agree on that. Similarly, if an object is moved to a location, like the floor, so there's no person receiving the keys, but rather John threw his keys to the floor, that means, okay, the keys ended up on the floor. That induces a strong preference for the second variant, and the first one comes across as being really, really strange, because it seems to imply that the floor is somehow animate, expecting the keys, trying to catch it, and so on and so forth. Yeah? So a mismatch for the category that we have in mind, yeah, for the situation. Right. So lots of, conditioning factors are a bit more subtle. So they don't yield impossible choices, but rather just preferences. For example, indefinite determiners. So if the transferred object is marked by an indefinite determiner, there is an ever so slight preference for the first variant. Yeah? So the second one also works, but given the choice, people gravitate towards the first. And inversely, the opposite is true for transferred objects that are marked with the definite article. I'm showing you all of this just to make the point that speakers of a language form categories at different levels of linguistic complexity, and that these categories are context dependent and quite often just partially open to conscious reflection. So in a case like this one here on the slide, the two syntactic constructions, speakers might tell you that, yeah, okay, I think this one sounds a little better than that one, but they wouldn't be able to tell you why that might be, or how it is that they know that one is better than the other. Yeah. Okay, so across different levels of language, speakers operate with categories that have central prototypical members, and then there are more peripheral instances at the margins. And that process is influenced by context, both linguistic context and non-linguistic context. Right, categorization. Let me move on to another fundamental cognitive skill that underlies human language, and that would be pattern recognition. Okay, that sounds rather sober, but what lies behind it is actually fascinating. Yeah? So it's an almost uncanny ability to make sense, to extract meaning of just about anything. Yeah? So we're faced with a world that is bewildering and complex, and we are geared towards the perception of meaningful patterns, things that we recognize, explanations that help us understand. And let's face it, most of the time, when we're doing something, we really have to act on incomplete data. And what decides between success and failure is our capacity to fill in details. Okay, so to do the kind of Sherlock Holmes thing, to come to conclusions on the basis of incomplete evidence. That sounds very profound, yeah, but sometimes it has lighthearted consequences. For example, this would be a coat hanger that looks, well, like a drunk octopus who wants to fight. And once you see it, it actually takes enormous willpower to ignore that kind of information, to ignore that pattern that has jumped out at you. Okay, so, well, that seems like, you know, funny and coincidental and nothing to do with language. However, when if I had to answer, you know, what's the place where pattern recognition as a human superpower really shines the brightest? I would say, well, the most unruly, most complex and unpredictable phenomenon that we encounter each day, what might that be? It's language. Yeah. So the kind of sounds that we hear and the interpretations that we have to come up with. So that really requires a strong engine of pattern recognition. And the greatest need to project regularity onto incomplete and ambiguous information, that arises when we're talking, when we're having conversations, and we have a quick back and forth of spontaneous talk. So we need to understand words, we need to construct syntactic dependencies and structures, and we get one thing wrong and miscommunication might be the consequence. So that is really where I think pattern recognition comes into play. And what is astonishing is that children from a very, very early age onward are extremely skilled in extracting statistical patterns from the language that they hear. So I want to illustrate that. Again, many of you might be familiar with this. So this is an experiment that has become a classic piece of scholarship. So the researchers exposed 8-month-old infants, so definitely pre-linguistic, to recordings of what linguists call nonce words, so words that are not form-meaning pairings, they're just sounds. And in this case, sound sequences of 3 syllables, like, for instance, tupiro, golabo, bidaku, padoti. And importantly, when the children were presented with these sounds, the recordings didn't provide any acoustic cues to word boundaries. So all syllables were presented in an even rhythm without pauses between them. So what the child would have heard would be something like tupiro, bidaku, padoti, bidaku, golabo, and so on and so forth. Yeah, just stream of sounds for 2 minutes straight. Now, here's where it gets interesting. The researchers manipulated the likelihood of one syllable being followed by another very, very carefully. Yeah. So here, for example, I've given you the word bidaku, and that always appeared as such, meaning that every time you hear the syllable bi, you can be sure that the syllable da will follow. Yeah, there's no exception to that. And every time you hear the syllable da, well, again, you hear da, and then ku will follow. Yeah, no exception to that either. However, if we compare that, for example, to the last syllable of bidaku and the first syllable of the following element, well, sometimes we have bidaku followed by padoti, meaning that we have the sequence ku pa. And here we have bidaku followed by golabo, so it's ku go. That means there's an asymmetry in the likelihood of one syllable being followed by another. Yeah. So within these words, we have high transitional probabilities, and across words, we have lower likelihoods of one syllable being followed by another. And the question is, do the kids pick up on that? Yeah? Do 8-month-olds have the pattern recognition abilities to figure that out? Now, I see in your faces psycholinguists. What are these people? Yeah, so, why are you doing that to an 8-month-old? Well, we'll see that there's actually something interesting that we can learn from that. So what happened in the test phase that followed the training phase, there was a first phase in which the children heard just more examples of the same recording that they've heard before. Yeah, so more sequences of tupiro and bidaku and golabo and so on and so forth. And predictably, perhaps, the children realized that, yeah, this is more of the same, and they quickly lost interest. Okay. Bonus question. How do you think you measure interest in an 8-month-old? They won't tell you that, yeah, well, I thought the first minute was kind of interesting. After that, it became sort of repetitive. No, that's not a discussion that you can have with a pre-linguistic human being. But what you can do, so this experiment uses something that is called the pacifier rate paradigm. So the babies are equipped with pacifiers, and excitement is measured in terms of frequency, how fast the babies suck on their pacifiers. Yeah? So if they're bored, the sucking rate is going to go down. But if something interesting happens, you know, you can just imagine what's going on there. So this is where we get to the second test phase. So here, the children were exposed to a combination of syllables that were part of the nonce words, but arranged in a new order. Yeah? So for example, ta, ki, and bu were part of what the children had heard before, but arranged in a different order, and expectedly the children, wait, what is that? That is something new. That is something that I haven't heard before. And perhaps if we want to phrase this in a more worrying way, the child realizes, damn, I thought I had a generalization. But apparently there's more to it. Yeah? And there's good evidence to suggest that children are better at going back to generalizations and findings and revising those and coming up with alternatives. What this means, sorry. Infants keep track of the likelihoods of one syllable following the next, and even short periods of exposure yield this effect. And the surprisal value that cues in the detection of word boundaries, that's actually a very important prerequisite for later processes of word learning. So in a way, training pattern recognition in this way clears the ground for the work that happens later with joint attention and intention reading. Yeah? So the child is already a very proficient sound engineer, you might say. Yeah? And then later on, it becomes a master manipulator of others' actions and a very intelligent reader of thoughts that happen in other people's minds. And all of this builds on top of each other. Right, so pattern recognition, that's a key skill for word learning in that sense, detecting word boundaries. But it also is of importance at more abstract levels of language structure. So, for example, when children learn the word order of their respective languages. So here I want to briefly come to a study in which young children were confronted with 3 new verbs that appeared in somewhat peculiar orders. As for instance, the robot dacking the banana, or the robot the banana gopping, or tamming the robot the banana. So that still resembles English, but it stretches the limits of English in a little bit. Yeah? And the setup of the experiment was, again, that these verbs were used in concrete situations where they described physical events, and a child was playing with an experimenter. Let me show you what is going on. So here we would have the experimenter and the child in a lab with toys and contraptions like this, where a robot is hanging from a rope, and the experimenter would say, look, this is the robot dacking the banana. Yeah? And that would go on for a couple of minutes. Here we have gopping, so the robot, the banana gopping. You can see how this, this can fill an afternoon, more or less. We have tamming the robot, the banana. And of course, the experimenter would be very precise in using that order with each verb in exactly the same way, so that the child would have a chance to pick up on the regularity. The question, of course, is, well, if you present children with this kind of data, well, what will happen if you ask them to re-describe these situations? So let's suppose the experimenter says, all right, now it's your turn. So here's the robot, there's the banana, you go ahead, you do it, and you tell me what is happening. Will they say, tamming the robot, the banana? Or will they say something else? And if so, what else will they say? I think you have an idea, yeah, but let me show you the results. So the syntactic order that was reproduced with the highest degree of accuracy and precision across all age groups. So we have 2-year-olds, 3-year-olds, 4-year-olds. So the easiest one was the SVO word order that we actually recognize from ordinary English. So yes, the auxiliary verb isn't there. However, it still resembles what we know from ordinary English. So there we have all the children pretty much at ceiling. Here's where it gets interesting. So we have the two weird word orders, the robot, the banana gopping, tamming the robot, the banana. And it seems that as we go from the 2-year-olds to the 4-year-olds, the children get worse. Now, why is that? Yeah? Why do 4-year-olds apparently have a harder time learning a new word order? Isn't that counterintuitive? Well, no, it's not. Yeah, it's not, because at some point during the 4th year of life, children begin to form a very abstract syntactic generalization that captures general word order in English. So that generalization, subject, verb, object, can then be applied immediately whenever they hear a new verb, such as gopping or tamming. Yeah? And the results here indicate that, okay, this must be happening somewhat gradually. Yeah? Right. So what this suggests is that a 2-year-old, well, at least half of them or a bit more than half of them, they take it on faith that something like gopping is just a verb that behaves in a weird way. Yeah? But, well, who knows, you know, not every lexical item behaves in the same way, so this is probably what it is. Yeah? The 4-year-old is a much more experienced language user, and they are ready to discard what the experimenter did as some weird thing that they've never heard before. You know? So they will normalize gopping to the conventional pattern, and this is indeed what you find in the results. Right. With that, I would like to come to analogy, and so this is the part of my talk that requires a little audience participation. Fair warning, it will require your full concentration and mental capacities. So here we have arrangements of geometrical shapes in the left-hand side. And arrangement A corresponds to arrangement B, and the arrangement in position C corresponds to exactly one of the 4 candidates that are shown on the right-hand side. And your task is to select one arrangement for position D. All right, do I hear any suggestions? Okay, 4. I'm going to go with that, yeah? And you're right, of course, and I assume that your choice was motivated by 2 factors. So first, you've noticed that between A and B, the shapes, they stay the same. Yeah, so circle, triangle, square in that order in A and B. And then with regard to the fillings, we can interpret that as the filling going down 1 step. So white circle goes down to become white triangle, stripy triangle goes down to become stripy square, and the black square, well, it doesn't have a place to go down, so it goes up and becomes the black circle. All right. So if you've made that choice, you have constructed what is known as a proportional analogy, a 4-part analogy. A is to B what C is to D. And reasonings of that kind are really ubiquitous in everyday life. So Paris is to France what Stockholm is to Sweden, and so on and so forth. And so there's that general pattern of thought. And what is well, noteworthy about this is that we are reasoning not on the basis of substantial similarity, but rather we're reasoning in terms of similarity in relation. Yeah, and that, of course, is important also for language. I want to show you just one more example here. So if you have a look at these 2 pictures here, and you ask yourself, are they similar? Yeah. Many people would respond, yes, they are similar. Yeah, and I see people nodding. But the interesting question is, why are they similar? Yeah. So if you were a computer algorithm, you might be saying, yes, they are similar because the same child reappears in both pictures. Yeah. But that is not why we're saying they are similar. We're saying they are similar because there's a similar relation going on across the two pictures. You know? So we have the mother giving a drink to the child and the child giving water to the flowers. And you notice me using the word give. Yeah? So our language draws our attention to the similarity in relation. Okay. Now, what this means is that superficial similarities are sometimes less important than deep relational similarities. And that sounds very, very sophisticated and complex. However, so there's actually robust evidence to suggest that animals are capable of creating analogies. So here's an experiment that has been done with birds, with crows. And the birds were trained so that they were shown 3 displays, yeah? And they have to take the one on top and match it with one of the 2 that are below, yeah? And so they were trained with triplets where color was the crucial variable. So for example, in the second one here, we have 2 gray circles, and then we match the color of the circles with the color of the triangles down there, yeah? And that would be a match. In the first triplet, shape is the crucial variable, so we have 2 circles up in the first one, and then we have the 2 circles down there. So that's what the crows learned. And then they were given this. Yeah, it looks, to us it looks trivial. It's the same, really, and it is. However, note that here we have to make a decision that is not based on shape, that is not based on color. It is just the general idea that, oh yeah, we picked the same. But that, I want to argue, is really, really a sophisticated cognitive achievement to say that, well, yeah, it's the same on some higher level of abstraction, and the crows are perfectly able to accomplish that. All right, so analogy, it's at work in lots of places, but in language, well, it is, for example, at work in children's overgeneralization errors, so things like a child saying the doggy bited him, which from an adult perspective is an error, but from the perspective of the child, well, it really is a 4-part analogy where we have count and counted, start and started, paint and painted, and it seems only logical that bite would be bited. You probably all know that analogies of this kind have given rise to linguistics' unofficial mascot, the WOG. Yeah? So the WOG study established that children from an early age onward routinely draw on analogies in their language use. So it's not only overgeneralization errors, it's also going on elsewhere. Okay, now, how is this going on in the wild? An example of analogy in the wild can be seen from excerpts like this. Yeah? So here we have an adult speaker who is interacting with a child and a mother. And what I've highlighted here is the verb put in different contexts. So we have the adult and the mother using put, and then in the end, the child is using 2 instances of put. And this you can think of as a mini lesson, really, in the use of one particular word. And it's what has been called a variation set. Yeah? The verb put appears in different contexts, and that gives a basis for the child to draw analogies. Some elements in the context of put are held constant, and others are varied. So this is what you see here. So when you arrange the data in this way, it becomes apparent that the speech of caretakers really invites analogies. For example, analogies between Liz and the lady, or between the orange and the egg, or between the pronouns my and her. So these elements can be perceived as respective equivalents, not because they would sound the same, yeah, but rather because they appear in the same position relative to the verb put. Right. Ultimately, of course, the analogies go much, much further as the child compares the use of put to other verbs that occur in similar variation sets. So the child forms memories that become increasingly abstract and that capture generalizations across different variation sets. Okay, I'm having a look at the time here, so I want to come to the last process. So that's one stop on this tour of cognitive capabilities that I really cannot leave out in any discussion of cognitive linguistic ideas, metaphor. And well, the field of cognitive linguistics, of course, owes much of its character to the initial impact of a book with the title Metaphors We Live By. And in that book, George Lakoff and Mark Johnson offer a definition of metaphor that departs from earlier accounts that frame it as some kind of poetic device. So they argue that the essence of metaphor is really cognitive. It means understanding one kind of thing in terms of another. And when they came up with this, the claim was essentially based on linguistic data. That is, examples such as these here. She has published widely in the field of cognitive psychology. My dissertation straddles the line between linguistics and philosophy, or this article goes beyond the traditional boundaries of particle physics, or this finding has opened up entirely new areas of research. Now, what you see here, put simply, is that we have language about areas in space, and that language is used to talk about something that is a lot more abstract, namely characteristics of scientific disciplines. And what Lakoff and Johnson suggest is that we understand scientific disciplines in terms of areas in space, and that this understanding essentially boils down to links between those two very different ideas. So on the one hand, we have the domain of space that we understand very well in all of its component parts, such as an area, or being in a borderline region, or moving across boundaries, or discovering new territories. And then we take this more abstract domain of science and we fill in the details from the more concrete domain that we are very familiar with. Okay. This idea really has been foundational for the field of cognitive linguistics, but it took a while to approach those ideas really in a solid empirical foundation. How can we know, for example, if sympathy really feels warm? So when I say we received a warm welcome, or she gave me an icy stare, well, we have the language of temperature in that, but does it mean that we really think about it in that way? All right, so there are some amazing experimental results that have come about since Lakoff and Johnson. For example, experiments in which groups of subjects were asked to perform a number of tasks, culminating in imagining a scene of either social inclusion or social exclusion. Yeah? So remember that time you were at home with your family for Christmas and it was just nice and cozy. Or remember that time when in physical education people were selecting teams and it was the most terrible 2 minutes of your life. Yeah? So those kinds of scenes people had to imagine, and after that the experimenter asked each subject to estimate the room temperature, not as part of the experiment, but rather just as something that would happen incidentally. And lo and behold, the two groups gave different estimates, with the socially excluded group giving lower estimates. Right. Well, we can even inverse the direction between source domain and target domain. So it appears that warmth, experiencing literal warmth, makes you feel more sympathetic towards others. So in this experiment, subjects were asked to hold something that is either warm or cold, on the pretense that the experimenter needed to fill out some papers and couldn't hold their drink for that time. So the participants were given either a cold drink or a hot cup of coffee. And after that, both groups had the exact same task, namely to complete a personality assessment questionnaire. So how trustworthy, intelligent, generous, responsible is a given person? And lo and behold, the same person was judged to be more forthcoming and competent and intelligent by the coffee group, who had been primed by a little interpersonal warmth. Yeah. I'm not going to hide that many of the experiments that proceed along these lines are difficult to replicate. So just this past week, there was an interesting study that came out that tried to replicate what's called the action-sentence compatibility effect, which argues that we understand language about motion in terms of cognitively simulating that motion. The same experiment has been replicated across 18 different labs. No effect. Nada. Nothing. So I guess a general rule of thumb is the more sensational an experiment looks, the more caution maybe is in order. However, I'll leave that to you. Yeah. I guess for metaphor, the literature is so large that it won't really all crumble to pieces. There is something there. Right. And with that, I want to revisit the forest that we're starting out with. So I hope to have conveyed the idea that behind the words and behind the structures of language, there are intricate cognitive and social processes at work that allow us to better understand language and how speakers are using it. Joint attention, attention reading, categorization, pattern recognition, analogy, and metaphor. There are just 6 of those that researchers in cognitive linguistics consider to be central. And they provide the foundations for language use in human beings. And taken together, they serve to explain a wide range of linguistic phenomena. And as I've been pointing out throughout this talk, everything is connected. So joint attention and intention reading, they go hand in hand in processes like word learning. Analogy draws on the ability to recognize patterns from noisy input. Metaphor relies on our ability to categorize objects and events in really complex ways. And it's due to these interactions that language has the characteristics that it does. So a forest can at times appear dark and mysterious, but someone who's familiar with its inner workings will see it with different eyes. And I'm perfectly aware that the ideas that I've presented today, many of those will leave you with more questions rather than with final answers. But also that, I think, is a very welcome result. You're ready to take a walk through the forest and discover new things along the way. At least that is something that I would be very happy about. So with that, I would like to thank you for your attention. And if there are any questions that you would like to ask right now or later, I'll be glad to discuss them. Thank you very much.
Thank you, Martin, for this wonderful talk full of insightful experiments, even if apparently not always entirely replicable. So, yes, we have time for questions, discussion. Yes, Dwight, please.
I guess I should keep the mask on, but I guess you can hear me.
I can, but you can, for the question, I think it's okay.
Yes, you can take your mask off for the question, of course.
I've been sort of an outsider most of my life, but this question sort of reflects that. And I first want to thank you for your excellent talk. My question is something that I've been mulling for quite a long time. And specifically, wouldn't it be great if someone, in my opinion, someone could write a book on what language cannot do? Now, for example, colorblind Mary experiment. She sees color for the first time.
Yeah.
Can language define what she sees? Now, there's no childhood color that she's experienced.
Yeah.
She sees color, and as an adult, she's an expert at cognitive abilities. Question is, where is language in this situation? I'm beginning to, maybe it's my age, but there's a difference between something and nothing. Is language trying to categorize me into a way of thinking that may not be accurate. The Hindus believe that there's something and nothing in their religion. And so this opposite, we're down to physicalism approach to something versus dualism. And so I'm beginning to just get lost about language. I had a couple of things else, examples. Well, for example, the Big Bang. Nobody knows if there was a universe before this universe, but the evidence seems to be that without the evidence, we assume there was a Big Bang and nothing before, no time before. Yet some scientists are peeking in the word, but there was a potential. Now, is potential before the Big Bang? I don't get it. So, again, the question, I could go on, but I don't want to bother you, but the question is, I mean, it would be to see what language does and its accomplishments. It would be great to have the devil's advocate point of view on limitations. Do you have any thoughts on any of that?
Okay. So 2 lines of, so I can't give you a coherent response here, okay, so I won't even try. But, so the 2 things that came to my mind.
Yes.
So the first was the thought experiment by South American writer Jorge Luis Borges with the Library of Babel, where you permutate all possible sequences of letters until you have all possible 300-page books that could theoretically exist. And in that library of books, you would find not only the story of your life, you would also find the story of your life with a slightly different beginning or ending, and so on and so forth. You would find descriptions of all things that ever happened, all theories that could ever be devised, and so on and so forth. I've been discussing this with a physicist. Unfortunately, there are not enough molecules in the universe to construct that library. However, the library represents a theoretical possibility of what could be expressed with language. So, and well, I find it really hard to fathom that there would be anything that could not be expressed. Yeah. So, given that language is always approximate, and we can sort of make sense of pretty much anything. The second, and this is perhaps the most, the more, well, directly relevant idea would be the research tradition on the Sapir-Whorf hypothesis and whether or not your language constrains any thoughts that you might have. Yeah, and there, well, again, the strong version of that hypothesis that well, your language really makes it impossible for you to have certain thoughts. I think that has been more or less discarded. So there are Whorfian effects that can be observed, but those are more, well, tendencies or habits that we have as speakers of a certain language to think in a certain way. Probabilities, you're right. Yeah, so I would, those are the 2 avenues I would explore, yeah, but it's clear that I would have to think about this a lot more. But so if there were a book, things that language can't do, I would want to read that book. So, definitely.
I'll throw in free will.
Okay.
Now, we do have the words free will, but our thinking is so cause and effect. And yet the contrary, without free will, how can you know that there's no free will? This is the skeptical argument from 2,000 years ago. You can't stand out and see what's really there because you're part of the cause and effect. Yeah. Now, I don't know if that's the fault of language or just the way we think today.
I think so, but then again, so I'm not nearly as familiar enough with the literature on free will to say anything intelligent about that. But I do think language is not at fault in that area as well. So there's a lot of things that we can say about language and language structures and language processing and how language is used in human interaction that, well, that it will survive any shocking news that we get about the existence or non-existence of free will. But again, that's my 2 cents that should be taken not as seriously, I guess.
Martin, you started with Chomsky.
Yes.
Saying that you want to convince us that Tomasello's approach to language acquisition, that we don't need a language gene because we have pattern recognition, joint attention, intention reading, categorization, etc. And these processes are enough, and we don't need a language gene. What if we have these joint attention, intention reading, pattern recognition, and categorization as a result of working of the language gene? And if these processes were first developed for language and then generalized to other cognitive processes, how would you falsify this defense of Chomsky?
Well, so most of the processes that I talked about, they're shared with other species, right? So categorization, I want to say that single cell organisms can be observed to behave in a way that reflects categorization of some sort. And of course, well, cats and dogs and primates, they can do much more complex things. So dogs, for instance, are kind of special case in the animal world in that they're able to engage in joint attention. So you can play a game where you throw a stick, and there's definitely a triangle of intention there. So I don't think that is the first line of discussion that could be had between the two camps, as it were. So the crucial question, of course, is: are these processes enough? Yeah, and is it even possible to come to a situation where you can reasonably say, all right, I think this is it. There's final, or there's plausible evidence that we don't need anything more. So what cognitive linguists have been doing up to this point, I think, is that we've been using we've been looking at phenomena that were presented as requiring universal grammar, and trying to argue that, look, with these ingredients, you can actually get there without anything else in addition. But your question had a second part about the, use of these processes for certain purposes and then others over evolutionary time.
I'd rather discuss one of your arguments.
Okay.
Going back to the second part of the question, because you said that many different species show these processes.
Yeah.
But you also said that many different species communicate.
Yeah.
Only not as effectively as we do through language. So it's a combination of these processes that we have, that we might be genetically endowed with, and they don't, because they lack this one little thing that makes them capitalize on all of those processes.
Yeah. Well, that is that's the big question. But I would say the difference in perspective is this. From the cognitive linguistic perspective, we would, the working hypothesis is that these processes, they interact, and that leads to language as an emergent phenomenon, something that doesn't need the language switch or the language gene or something that is exclusively dedicated to that. So the spark, if you like, comes from these different processes coming together. And each of these processes, that's something that I didn't really go into in a lot of detail, but they are, they come in shades, right? So primates clearly have a sense of the mental states of other conspecifics. So I have a fantastic colleague, Klaus Zuberbühler, a biologist at the University of Neuchâtel, who studies primates in field research. So he actually goes out, and they do quite mean things to those chimpanzees. So they hide models of snakes along paths where they know the chimps will go regularly. Yeah, and then they put cameras there and observe the chimpanzee's behavior. And what happens is, so I'm reenacting this thing here. So the first chimp will come along and will see the snake, and will be in panic for a little moment, and then they will look back at the others, and if they see others emit some kind of warning call, yeah. But there's clearly some kind of reflection. It's not automatic. Okay, see the snake, warning call. That's how it works in little macaques and monkeys like that. No, it's more of a okay. Do the others need my information right now? Yeah. So that kind of process is definitely there. However, well, there are some gradual differences, and so I can imagine. But again, here we're entering the hypothetical that. It could be that all of those processes are really present to some extent in other species, and that, that gradual extensions in each and every one of these suddenly gives rise to an emergent phenomenon such as language. Now, I'm perfectly aware that a very valid criticism to that would be, okay, so you're assuming that at some point the magic just happens and you're happy with that, yeah? Well, but to that I would respond, well, your theory also has this little magic thing, yeah. So the mutation that suddenly puts everything into its place, and you have language. Is that any better? I know that hasn't satisfied your question, but that's the kind of approach that I would take answering.
Thank you. Thank you. And
well, actually, the discussion sort of answered my question, questions, what I would call it, but I was interested when you were talking about the joint attention and intention reading, and I immediately thought of, I mean, animals obviously have joint attention in some species anyway, but the idea of intersubjectivity, understood as imagining what your interlocutor is thinking,
yeah,
guiding your communicative endeavors. Does that exist in other animals? And how does that relate to intention reading? Mm-hmm. And your chimpanzee example would suggest that it does exist in other animals.
So there's a wealth of information on that from just experiments with primates, not only these things that are happening in the wild, but also in controlled situations, for example, where, you have a setup with two chimpanzees, one dominant, one subordinate, and you have an arrangement of food, and the subordinate chimpanzee knows that the other chimpanzee is aware of that food. So in that kind of situation, the subordinate chimpanzee would not even try to get that food because they are aware, okay, so if they have this counterfactual reasoning going on. If I go there, the other chimp, on the basis of their state of knowledge, will want to get that food, and they will beat me up if I try to take it. Yeah. On the other hand, if you manipulate the experiment in such a way that the dominant chimp is not aware, then the subordinate chimp will try to be sneaky and get it while the other isn't looking. And there's even, a variant of the experiment that takes it even further, operating with false beliefs. So where you instill the belief in the subordinate chimp that the dominant one is aware when they're actually not. So again, so primatologists, they're just about as crazy as people working with infants and psycholinguists and other people like that. So definitely. So awareness of intentions, that's definitely there to different degrees, I would say. And the interesting thing at that point would be to try and research how this continuum of intention and awareness is structured. So if there is anything qualitative that is really different, or in what way our abilities go beyond what our closest relatives can do.
Is this another fundamental cognitive process, skill, capacity, or is there something fundamental that is both, which is, you know, attention and, I mean, because that was a nice, neat list of things, and I'm just a bit nervous about how many other things could be. One of the criticisms of cognitive linguistics is a sort of ad nauseum list of cognitive things that, yeah, exactly. Yeah. Every time there's a new phenomenon, we just come up with a new way of our brain doing that. I mean, do you think there's like a finite and discrete set of cognitive processes, capacities that are needed, or is it more messy than that?
Okay, so I definitely agree that the labels are messy. So for example, if someone were to ask me, okay, what's the exact difference between schematization, categorization, and routinization? I would be explaining these things to myself, making things up as I go, right? So more or less, it's a caricature. But it's true that, well, we can probably agree on, okay, this skill should be there, and we should probably define it through things that we can observe, through experiments or through other measurements that we can take. So that's probably the problem, that most of the terms that I've given you, they lack a proper operationalization that really everyone agrees on. Yeah, but that doesn't take anything away from, well, that's a direction that I think we should go into. And yeah, I don't consider it as much of a problem. So what you've suggested is that, yeah, okay, this turns cognitive linguistics in this kind of ad hoc theory that we adjust as needed. So there's a problem, okay, we adjust the theory as needed and go on about our business. I don't think that's 100% fair, actually. I think the predictions are very clear, and also the way to falsify the theory, if we want to adopt this kind of hypothetical deductive falsification paradigm, that I would say that is more or less satisfying. Not everything is neat and tidy, but I think if you wanted to go and falsify these things, then that would definitely be possible.
I'm convinced on cognitive.
There's also this, on the subject of awareness of attention, I guess most of us have had the experience of just randomly looking back and right at the person who's looking at you, catching your eye at that person.
Yeah.
But this gets in another broader question. We use the word coincidence, and who knows if that explains what's happening in that or in other cases.
Yeah.
Use that word.
But our peripheral vision is excellent, right? So
yeah.
So your eyes have a tendency to jump to things that you didn't really pay attention to, but your vision was picking up in the periphery. And yeah, I don't know.
Okay, do we have any other questions, comments? We don't see any hands up, so thank you, Martin, again.
Thank you for your
attention. Yes, we did. There were no questions online.
There are no questions.
Maybe you'll get a few emails here and there.
I'll be happy to answer emails. Not only from the people online, also if there's someone in the room. Yeah. If something comes to your mind this afternoon, feel free.
Thank you.
Thanks a lot for having me. This was great fun. Thank you.
Once again.